this is the Where Does Spaghetti Like to Dance worksheet, and we're just going to go through a few of the problems in each part, just so that you know how to do them, and the rest of the problems can be solved in the same way. So part 1 says match each graph, so these graphs here, to the correct translation. So down here we have a list of different translations. 5 of them will match up, 1 for each of these graphs, and that will give us a number and letter combination we can write down here. So let's do number 1 first of all. So really important to note which one of these shapes are the original and which shape is the translated shape. So here it says that the original is going to be A. So A, and the first one is right here. And the translation is the A with a dash, which is A prime, is how we say that. So A is the original, and A prime is this shape over here. So now we need to find how A was translated to get to A prime. And to do that, you can, well, there's a few ways you can do it, but one way that always works is pick a vertex or one of the corners on the original and find the corresponding vertex on the new shape. So in this case, I chose the top left corner of the square. And then you can just count how far the shape was moved up or down, so vertically, and how far the shape was moved left and right, horizontally. So in this case, it looks like A was moved down 1, and 1, 2, 3, 4 to the left. So now down here, we're going to look for left 4, down 1. And it looks like we got it right here. So next one, you can write left 4, down 1. Like that. So if at the end it doesn't make any sense, writing it down next to the number is a good way to be able to go back and check your answers quickly. So you can always just look and be like, does this look right? Left 4, down 1. Yep. So now we know that number 1 corresponds to T. So you come down here, find 1, and you can write in the T. So now let's do the second one here. So this time, this triangle on the left is going to be A, and this triangle down here on the right is going to be A prime. So we want to see, how did A get to A prime? How was it translated? So once again, you can just pick one of the vertices. It doesn't matter which one, as long as you pick corresponding vertices. You don't want to pick the bottom right point of this triangle and then the top of this triangle. That's not going to give you the correct answer. So now we just want to see how far was it moved horizontally and how far was it moved vertically. So we can count here. 1, 2, 3, 4, 5. Looks like it was moved 5 to the right. And then vertically it looks like it was moved 1, 2, 3, 4 down. So we can write right 5, down 4, and then look for that down here. And it looks like right 5 down 4 is going to be E. So wherever we find 2, we can write an E down here. Alright. Part 2 is a little bit different. This time we want to translate the given image, so a triangle over here and a quadrilateral over here, to find the new coordinates of the vertices. So we'll do one on each. So over here on this triangle, let's look at A. So the letter A corresponds to translate 6 to the left and 4 down, and ask what are the new coordinates for A. So we'll move the whole shape 6 to the left and the whole shape down 4. And you can do that vertex by vertex, so why don't we start with A, seeing that that's the one we care about. So you can either work out the coordinates of A, and we'll do that, or you can just count the squares. So let's start with finding the coordinates for A. So A is at 1, 2, 3 on the X. So So A equals 3. And its Y is 1, 2, 3, 4, 5. So A is at 3, 5. And remember, when you translate, you can just add or subtract from each of the coordinates. So we want it to move 6 to the left. So that's going to be -6 on the x, because you're moving to the left. And you're wanting to move 4 down, which is going to be negative on the y. So it's going to move 6 to the left, 4 down. So it's going to look as -6 on the x and -4 on the y. So then A prime should be at 3 minus 6, which is -3. And 5 minus 4, which is at +1. And then we can check that by doing the other way, which is just counting the number of squares. So we're starting here, and we will go 6 to the left. So 1, 2, oh. There we go. 1, 2, 3, 4, 5, 6 to the left, and down 4. 1, 2, 3, 4. So A should end up there. So that would be A prime. And if we look at what those coordinates are, we are at -1, 2, 3 on the x and +1 on the y, which is what we got. So now you can come down here, find -3, 1. It looks like it's going to be right here, and write the letter of the problem we were doing, which was A. Alright, and let's do one for this shape. So let's do the M. So the M says translate 8 to the right and down 3. What are the new coordinates for B, or B prime? So B starts right here, and that's going to be at -2, -1. So that's what B equals. And B prime, we just want to add 8 to the x, because we're moving to the right. And we want to -3, or subtract 3 from the y, because we're moving down 3. So again, you can write that as +8 for the x, and a -3 for the y. So then B prime is going to equal -2 + 8, which is +6, and -1 plus -3, which is -1 minus 3, which is -4. And once again, the other way we can do it, and a good way to check, is counting those squares. So B is here, we want to count 8 to the right. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, sorry. And then down 3, 1, 2, 3. And so B prime should end up around the edge of the graph. So it's 8 to the right, 3 down, and if we count the coordinates, we should have 1, 2, 3, 4, 5, 6, and -1, 2, 3, 4. So 6, -4, and B prime. So then you want to finally come down to the bottom here, find 6, -4, right here, and write in the letter of the problem we were doing, which was M.